Hi, my name is Audrey Olenski, and I'm going to be discussing Physics 2212 Lab 1 about charge tapes. I'm going to begin with an introduction to this lab and some background of the material. In this lab, we use charged Scotch tape to understand how electrons are transferred in everyday objects. This lab depended on a few basic physics principles. Newton's third law and the rules of equilibrium show us that when stable, the forces of a system are equal but opposite of one another. Coulomb's law, shown on the screen, is also essential to this lab in calculating the electric force on the charge tapes. This experiment can be broken into 3 parts. To begin, I created charge tapes used for the observation of charge, attraction, and repulsion. To do this, I stuck a piece of tape on a table, then added another piece directly on top, referred to as the U-tape, which can be seen on the top picture on the right. I then quickly removed the U-tape to transfer the charge to this piece. Using this tape, I was able to make observations regarding the charge on the tape. More on this in the next slide. Following this, I created a floating tape system using 2 pieces of charged U-tape. The effect of this can be seen in the bottom right picture. The final step of this lab was to model the system in GlowScript using Python. This lab did require assumptions to be made to simplify calculations. First, air resistance had to be ignored on the tapes. Additionally, when modeling the system, the pieces of tape needed to be treated as point charges, meaning that all the charge would be concentrated at the center of the tape. Lastly, I assumed that each U-tape had the same evenly distributed charge. Next, let's discuss measurements and calculations for the floating tape section of this lab. The first step of this lab allowed me to make observations about the charge on the tape. First, the charged U-tape and my hand were attracted to one another. Secondly, 2 U-tapes put near each other were repelled. Third, U-tape was attracted to my neutral notebook. For the last interaction test, I ran a plastic pen through my hair which created negative charge on the pen. When the U-tape was put near this pen, they were attracted. We know that like charges repel and opposite charges attract, so this experiment proved that the U-tape was positively charged. After performing my interaction observations, I conducted the floating tape experiment. To begin, I found the distance between the 2 tapes when floating, as depicted by the bottom picture. My distance d of 0.03 meters was found by averaging the distance of 3 trials. Then, using the mass given of the tape, I calculated the force due to gravity. To perform my calculations, I began by finding the charge on the tape. Because the system is in equilibrium, the net force in the y direction is 0. This means that the gravitational force pulling the tape down is equal to the electric force pulling the tape up. By rearranging Coulomb's law, I found that the charge on the tape was 1.401 times 10 to the negative 8 coulombs. Next, I calculated the number of electrons on the top tape B. To do this, I divided the charge I found in the previous step by the charge on a single electron. This equaled 8.754 times 10 to the 10 electrons. Next, I calculated the number of atoms on the tape by dividing the area of the tape by the area on the atom. To calculate the area of the tape, I multiplied the length of 0.2 meters by the width of 0.02 meters. I then found the area of the atom by using the diameter. These calculations led me to find 4 times 10 to the 7th atoms on the tape. Lastly, I found the ratio of electrons to atoms. To do so, I divided my calculated value of excess electrons by atoms found in the previous step to get 2.189 times 10 to the negative 7 electrons per atom. For the last step of this lab, I modeled this system in GlowScript using Python code. This conceptual model depicts each tape as a single point charge. Tape A is represented by the yellow sphere on the bottom, and tape B is shown by the green sphere above. The red arrow pointing up is the electric field, while the orange arrow shows the gravitational force. The calculations printed below the model align with those done by hand in the previous steps. To conclude, I want to discuss some considerations brought up by this lab. To address the first question, flipping the charge on electrons and protons would not change how the objects behave. Like charges always repel one another, and opposite charges will always attract one another. Because of this, it doesn't matter which point charge is positive or negative. Regarding the second question, handling the tape as little as possible gives the most pure experimental results. The more the tape is handled, the more the positive charges start to neutralize with your hand. This concludes my discussion of Lab 1. Thanks for watching.